Welcome to Maths for You channel. A past question on vector. A couple of diagrams, a quite detailed diagram, and some words. Figure 1 shows a rectangle with sides of 7 units and 3 units, from which a triangular corner has been removed. It's a dotted line triangle, leaving 5 sides a polygon, OA, BCD. The sides OA, AB, BC, DO have lengths of 7 units, 3 units, 3 units, and 2 units respectively. Figure 2 shows the polygon OABCD forming the horizontal base for a pyramid in which the point E is 8 units vertically above D. Unit vectors I, J, K are parallel to OA, OD, and D respectively. Find C and the length of C. It's a pretty detailed diagram and wordings. But if you look at the marks, only 3 marks. So it's just the question supposed to be pretty straightforward. Let's start. They ask you to find C, vector C. In that diagram, second figure 2, C, we need to find a triangle, vector triangle, or vector diagram with C as one of its sides. So we can get the vector triangle DCE, which has C as its side. So take vector triangle DCE to find C. So vector triangle. If you look at it, that DCE is a right angle triangle, but we don't need that detail. But just if you look at it, a bit of solid geometry or three-dimensional geometry, it is right angle triangle because of E, the straight above, vertically above D, and then any line on that line horizontal plane, that is DC, is supposed to be or must be perpendicular. But we don't need that detail. So all we need a triangle, the vector triangle. So to find that CE, we need to work out other two sides, D vector, DC vector, whichever. So the other two vectors we need to know. We do know that D is 8K because of E is parallel to K, D parallel to K, and 8 units, therefore 8K vector. So vector D is 8K. But DC we don't know. But what we can find, we pick up another triangle, the dotted line triangle, a right angle triangle. I just named the corner X. So DXC, that triangle, to find DC. From the vector triangle DCX, dx plus xc equal dc. Dx is the 1 unit and parallel to j vector, unit vector, therefore 1j, plus 4i, 4 unit, it is parallel to I vector, unit vector, therefore 4i equal dc vector. So the dc vector is 1j plus 4i. From the triangle, we go back to that first triangle. From that vector triangle DCE, now we know DC. We need to find CE. but we know DE, that is 8K as well. So C from this, if you take DC the other side, D, vector D minus vector DC. Vector D is 8K minus vector DC. We found J plus 4I, 1J plus 4I. So that will be, if you could sort of write it in the proper order, minus 4I minus J plus 8K is C. So we found the vector C. That's the first part. The second part of the first question is we need to find the length of C. The length of C is the modulus of the vector C. Modulus of vector C, the coefficient of ijk squared, and sum of that squared. So square root of minus 4 squared plus minus 1 squared plus 8 squared. Minus 4 squared is 16, minus 1 squared is 1, minus 8 squared is 64. 64 plus 8 is 16 is 80. 80 plus 1 is 81. So square root of 81 is 9. Square root of 81 is 9 units. So C is 9 units. So first part done. The second part is use a scalar product. So they just give us the idea of how we can do it. Use the scalar product to find angle ECA. Give your answer in the form of cos inverse m over root n, where m and n are integers. Okay, right. Now we need to find the two vectors which form ECA. So if you look at the diagram closely, ECA, we need to find the angle ECA. So the vector C, vector CA, if you could find those two, then obviously we can use the dot product. But CA we need to find it. C already we got it from first part. CA. So get the CA. If you look at the figure 1, the CA is the hypotenuse of ABC triangle, right angle triangle. So that take triangle ABC and CA we need to know. But we know AB is parallel to J and the units is 3. So 3J vector. AB, 3J vector. And again, CB is parallel to I and 3 units, so 3I. So from the vector triangle ABC, CA, CA plus AB equal CB. This vector CB is a vector addition. CA we need to find, so CA equal CB vector minus AB vector. CB is 3CB is 3I, and AB 3AB is 3J. Yeah, minus, sorry. AB is 3J, so minus 3J. Now we need to find that the dot product. So C dot CA, vector C dot CA, the dot product of CA equal the modulus of C first vector, the modulus of second vector CA at time cos theta, the angle between the two vectors is theta. That is what we have to find. So from this equation, we can find cos theta. Cos theta is C dot CA, C dot CA divided by the modulus of C times modulus of CA. The vector C we have found from the first part, that was minus 4I minus J plus 4K dot, and CA we just found it, 3I minus 3J. So I, J, J, K, K should be multiplied. So the coefficient of I is minus 4, coefficient of 3. So 3 times minus 4 is minus 12. Coefficient of J, the minus 1 minus 3 is plus 3. and k, there is no k here, or maybe 0k, 0 times k, that is 0 times 8 is 0. So minus 12 plus 3 divided by the CE. CE is, we already found 9. CA is the modulus of vector CA. As on this here, on this side, left hand side, it's 1. Modulus CA equal the square root of 3 plus 3, square root of 3i, the coefficient of 3i, coefficient of j. So 3 squared plus 3 squared is 3 squared is 9, 3 squared is 9, inside 18, root 18. So just put that CA, modulus CA is root 18. So minus 12 plus 3 plus 0 divided by 9 times root 18. The minus, 9, so minus 12 plus 3 is minus 9. And then 9 cancelled out. What we left is minus 1 over 18. So that is cos theta. Therefore, theta is cos inverse minus 1 over 18. Minus 1 over 18. What we need to find in the form of m over n. So in the form of m over n, if that's so, m equal minus 1, n equal 18. Yeah, that's a form of, say, theta equal cos inverse as m divided by square root of n in the form of the form we have to produce the answer, which we have. Just cos minus cos inverse is minus 1 over root 18. M is minus 1, n is 18. Thank you. Please subscribe the channel and share the contents with fellow students and friends. Thank you.